in this Python tutorial on astronomy and astrophysics, our objective is to learn that how to create an inset or zoom in plot from astronomical FITS images. I guess you must have somewhere seen these kind of images in either your uh, newspaper articles or some scientific journals or some research papers in which these plots are like very common to visualize objects in the crowded field. So this type of plotting is required when you have a very crowded field of astronomical sources and you want to focus in a very smaller region or patch of the sky to visualize that what objects the source the source region contains. So here you can see that I have a sample of the zoom horizon plot. So here you can see that I have this red square box is containing the very smaller region of the sky, and its corresponding zoom or inset plot is given in this subplot. Okay, so this bigger plot is the zoom in version of the square box region. So this kind of plot is like useful to visualize your data or image in very narrower or finer region of the crowded field. So same stuff we are going to do it using Python coding, and I will be using NumPy, Matplotlib, Astropy and Ampere toolkits to do such kind of plotting. Right, so in order to make your life easier in this Python tutorial, I have designed a workflow which will go in the following steps. So total I will be going in 9 steps. So step 1 will be to download your FITS image file from Sloan Digital Sky Survey telescope, and then I will import required library. In step 3, I will read the FITS image file through Astropy library, and then in step 5, step 4, I will extract the image data, which is a 2D data, and then in step 5, I will plot and visualize your image data. After that, I will start doing preparation for the inset plotting. So for that, I will define an inset region on the 2D image, and then I will give its location and the size of the plot, and then I will upload the zoom in region in the inset, and then I will mark the zoom in region connected to the main plot. And if time permits, I will go to create multiple regions of inset image. So this is my workflow in which I will be following throughout this tutorial. So let's start with step 1. So in step 1, we will be downloading SDSS FITS image file. Okay, so I'm not going to download this image file once again, because you can watch my day tutorial on how to download FITS image from SDSS website, and here's a link of this tutorial I have given, or I will attach the link to this tutorial in the video description or Alternatively, you can click on the right corner of this video and you can watch this video how to download the image, or just let me click on the link, see where it will take to you. So here is the tutorial with this title, and you can click on that. Okay, now come to a step 2, in which we'll be importing the required libraries. So first of all, I will import NumPy as np. So here np is your alias for this NumPy library. You can make anything, say jp or mp, you can also do, but I will go the tradition with NumPy. So this deals with numbers and arrays, right? After that, I will import matplotlib for plotting. Okay, so import matplotlib dot pyplot as a plt. So this deals with your data visualization. Okay, and then I will import Astropy. So from astropy.io input output import FITS. Okay, so this deals with FITS file handling, right? Writing, reading, and doing other stuff. After that, I will import library for Inset plotting. Okay, so for that I will use library impaired toolkits. Okay, so from npl toolkits dot access grid 1 dot inset grid 1 dot inset locator import your inset axis and inset mark. Okay, mark inset, not positive. Okay, mark inset, right? So this deals with your inset plotting, right? So we have got all 4 required libraries. What is mistake? Import, there is some mistake, there is an extra O. Okay, so now step 2 is completed. Now I will go to a step 3. Okay, so read FITS image file. So for that I will check my file here, or just give a file variable name here, file. Okay, and then give the function FITS.open, right? And then give here your file name dot your extension. Okay, so let me check which file I have. So type here ls star dot fits. I think yeah, maybe you need to. Okay, let me go to here and type here ls star fits. So I have so many fits file here in my directory. So I will choose this fits file. Okay, r dot fits. Okay, so this command is not working in this cell, so remove it and copy this file. Okay, r dot fits from here. Your file name may be different in your directory. Okay, so this reads fits file. Right? Now I will extract fits file information. Okay, so for that command here, file dot info. Okay, file dot info. So here you can see that my file name is r.fits number 0 for SDU. Name is primary. There is version 1. Primary SDU type. We have like cards, comments, and other stuff. Dimension. It has this dimension, and data type is Pro32. Right. Now I will be. Now what I will do? I will be extracting data. Okay, or you can do one more thing. You can like get here file header information if you want. So for that type here a file 0 for primary. Okay, and then dot header. So if you put here, you will get some information about the object array data and other stuff. Okay, you can like also put here say primary, and you will see must have so primary or 0, so both will work. Right, now I will extract the data. Okay, so define here image. So image data. Okay, data equal to file 0 for primary SDU and dot data. Okay, so if you print image data, see it returns some non values and some other value. Okay, so yeah, so if you put data say 500, so return some values. Okay, so it has some values, and you can also like check the shape of the data. Right, so image data dot shape. So data shape is my 557 into 1536. Okay, this is my y-axis. This is my so this is my rows, and this is my column. Okay, so this is how my data shape is. Now we completed our step 4. Now go to step 5. We'll plot and visualize the image data. So for plotting and image data visualization, I will be first creating a canvas for plotting. So type here figure, comma, axis, right, and then type here plt dot subplots subplots, and then you can give here figure size. So I will give 10:10, right? And see, it is turning a axis on the normalized x and y axis. Okay, so for time being I can change it 10:5. Okay, so this is my canvas for the plotting my 2D image. So you can see it goes from 1:1 or normalized x and y scale. Okay, so after that I will plot my 2D image. So for that I will type my x, okay, and x IMSO. Okay, so which show 2D image, and then I will pass my data color map, and if needed you can choose your origin and some contrast value, beam and vmix. So I'll pass my image data, right? So image data, right? And just run it. And so can also type here plt.show, not showing the image address. So here you can see that here is my image, but like only can like see two dots which are like very bright, right? So it is on linear scale. So what I will do, I will put this image on the log scale to visualize some sort of bright sources, right? So take log 10 of this data, and there is some runtime warning because in my taking log 10 of the image data, there are some net number value or some zero value or negative number, so it will discard that. That's why this warning is. So don't worry about the warning. So now here you can see that there is a two galaxy, there is one star and other features in this image. So what my job is to zoom this region into a bigger inset region, right? Now here you can see that my origin at lower left is not coinciding at 0, so go here and put origin equal to lower. Okay, so you can see here my origin is now at 0. Okay, and then you can give a color map. So you can make C map. So C map you can give a jet. So this is how my image is appearing in color image. You can give so many. You can also make it black and white. Right. You can also like reverse it if you want. So I will put the jet, or you can also like put rainbow. Right. So I will just go with jet. Okay. So here is my image, and we have to like zoom this region. You can zoom any region you wish, but I will only zoom for time being. I will zoom this region. Come to step 6. We will define inset region, inset location, and the size of the inset figure. So for doing the stuff, give a variable here x dot inset, right? And then you can insert your inset axis. Okay, so inset axis you create and see what it takes. So you can see it takes your parent axis width, height in terms of percentage of your main plot, and you can give the location as upper right, center, and upper left. So I will pass my main figure as a x, right? And then I can give width as a say 60%, right, of the main plot, and it can take a height. So height it can take say 40%, or you can give location, right? So you can give location. So location you can say location give say upper right. So let's see what this variable is going to return. So type here x inset. So just hit a Python object. Now this much we have done. Now I will be putting the region. Okay, so choose inset region. Okay, so I will create say rectangular region or a square region. Okay, so for that first I will define center. So you can define xc, right? Here xc and yc you can give some numbers. So you can choose for this object. So it is below it is around 200. Okay, so I can give from like 180 to 200. Okay, later I can change it, and then I can give my box size, right? And I give my say box. Okay, so box size equal to, you can give say 30, right? And you can also like change it anything, so make it 20, right? And then you can give its x and y coordinate. Okay, so x1 coordinate, x coordinate, right? So and then you can move from xc minus box size, and then xc and comma xc plus box size. Similarly, you can do this for your y1 and y2 also. Okay, so just copy this and replace your x as y1 or y2, and then make here yc and yc, right? So you can enter these are x1, x2, right? y1, y2, right? So these are your coordinates, right? So this much we have done. We'll go through step 7 and do the plotting of zoomed in region of the inset, right? So for that type here ax underscore inset variable, and for image type here info and pass my data. Okay, so I have image data. So take a log of that, log 10, right? And yeah, after that I will create a origin lower, right? So for matching, and I'll put a C map as a Z, okay? And then I will put the limit, okay, so that it will be visible on the. So for that I will put here X inset. I will set my X and Y limit, okay? So set underscore X limit, right? So X limit as a X1 comma X2, and similarly I will set limit for your Y axis also. So inset, it's there should be limit, not label, okay? So limit and limit, there should be Y, and there should be also Y, and there should be also Y, right? So the step is to mark the zoom region on the main plot, and you will also be giving the location of the inset plot and the edge color of the line connecting and the face color etc. So let's give a function here, mark inset, and you need to pass here your parent axis, your inset axis, your location of the connecting line to your main plot, okay? So give your main plot, right, X, and then your inset axis, then you can give say location 1, give 1, location 2, you can give 3, right? So the location will create the corner of the square to the inset plot, okay? Then you can give some face color. Face color you can give none for time being, and you can give edge color equal to say black, okay? So now our code has run successfully, right? And if you type here plt.show, so yeah, it is working fine. So now we need to like combine all codes in a single cell, okay? So just copy this code here and go to your step, go to your step 6, put this code here, and then go to step 7 and copy the code, right? And put it here, right? And after that you can go to this step 5, copy 2 lines of code and put it here, and now run the code. So here you can see that here is your image created that was required, okay? So you can see this is your smaller region, and corresponding to this smaller region you have this zoom or inset plot for this region. In a more finer details you can see of the object, right? You can also like control the size from here if you want, right? So you can make it say 40% and 30% of the figure size. Okay, so it will get a smaller, right? And you can also like change this color, so make it red. You can see this lines will be changing its color. Then you can give its line width if you want. You can give it say line width. Line width you can give say 3, so line will get thicker, right? You can make line style equal to dash, so these lines will be broken. Okay, this is how we can see the stuff. So make it height 60%, right? So this is how things are visible, and you can do like one more customization. Yeah, that's fine. You can do the this location correction. Okay, you can see this dot, these lines are connected with the right color of the image. So go here, change the location say 2 and 4. So this time they are connected at the diagonal. You can make it say 1 and 4. So here 1 and 4. Okay, so this way you can change this parameter also, and you can also like change its plot size. So make it say 50% and make it say 100%. So this is my image will be like covered fully on the height and some portion of the width of the image, right? So this way you can do the stuff, right? So I hope you got the idea that how to plot, zoom in or insert plot from a smaller or finer image region. So let me review the code once again for your sake of completeness. So I have first I have downloaded your FITS image, then imported some libraries. After that I have Raed FITS image, then got some header information about the FITS file. Then I have extracted the data, 2D data, and I have like put this image on the log, taking the log of the image data. Then I have defined the inset region, right? After that I have plotted a zoom region in the inset, and after that I have marked the region and customized its location, its color, face color, etc. So this is my final product, you can see here, and I hope this tutorial is helpful for you to learn this kind of plotting. And in case you got any problem in reproducing this kind of plots, you can let me in the comment section. I will be happy to help you. So thank you and stay tuned for the next videos.